Section 7.5b, matrix multiplication. If matrix A is an m by n matrix and matrix B is an n by p matrix, then AB, A times B is an m by p matrix, and B times A is undefined. First thing to notice from this definition is because A times B gives us an m by p matrix and B times A is undefined, we know right away that matrix multiplication is not commutative, meaning that it does matter the order in which we multiply things versus standard multiplication where 9 times 6 is the same as 6 times 9. When you multiply matrices, and this will make more sense when we look at some examples coming up, but when multiplying matrices, you have to remember that you move across rows and you move down columns. And you'll see that when we look at some specific examples. So looking at the first part of this definition again, matrix A times matrix B. Well, we know that matrix A, we're told, is an m by n matrix. Matrix B, we're told, is an n by p matrix. The way that you are going to know that you can multiply two matrices together is when you write the order m by n and n times p. If these middle two numbers match, then you know that the multiplication exists. More than that, once we know that those two middle numbers match, this outside two dimensions are the size of the matrix that you get, which is why A times B is going to be an M by P matrix. If we look at the other direction, matrix B times matrix A. Well, we know matrix B is N by P. Matrix A is M by P. I'm sorry, M by N. And if we go to look now at the middle two numbers here, we can clearly see that those two middle numbers do not match, and that's why B times A is undefined. So that's the first thing you need to check every time that you are multiplying matrices. Make sure that the product exists. If the product matrix does not exist, you obviously don't need to multiply it. You just say that the matrix is undefined. So looking at these two matrices here, matrix A times B is what we want to find. We know matrix A is a 3 by 2 matrix. Matrix B is a 2 by 2 matrix. These two middle numbers match. Since they match, we know the product matrix is going to be a 3 by 2 matrix. So now when we go to write that product matrix, A times B, we know it's going to have 3 rows, and we know it's going to have 2 columns. When we go to multiply these together, I'm going to do this for the first couple of them. Okay, you may want to do it for all of them because it really helps organize some things. We know that there are going to be 6 entries because we have 3 rows, we have 2 columns. The key to the multiplication is remember what row and what column you are trying to find the value of. So in our product matrix AB here, this first entry is row 1, column 1. So I'm going to look at row 1 along with column 1 in the first two matrices. Again, we go across rows and down columns. So the first thing I do, start at the beginning of row 1, start at the beginning of column 1, and I take -1 times -3. -1 times -3 is 3. We go across the row and down the column, and then I multiply again. 3 times -4 is -12. So what we get from the first entry, we have 3 plus a -12. 3 plus -12 is -9. There's our first entry. Our next entry going across this row is in row 1, but now with column 2. So again, start at the beginning of the row, the beginning of the column. -1 times 2 is -2. 3 times 1 is 3, so I have -2 plus 3, which is 1. Go to the next entry in our product matrix, row 2, column 1. So now I'm using row 2 in the first matrix, back to column 1 in the second one. 4 times -3 is -12. -12 plus 8 is -4. Row 2, column 2 entry. Row 2, back to column 2. Start at the beginning of the row, top of the column. We have 4 times 2 is 8. 8 plus a negative 2 is 6. Move on to row 3, back to column 1. Negative 15 plus 0. Finally, the last entry is row 2, column 2. 10 plus 0 is 10. There's our product, A times B. Example 6, letter A. We have a 2 by 3 matrix times a 3 by 3 matrix. Middle numbers match, so we know right away that we can multiply them. And our product matrix is going to be a 2 by 3 matrix. So this time we're going to have 2 rows, and we're going to have 3 columns. 1, 2, 3, 1, 2, 3. 3 columns, 2 rows. First entry, row 1, column 1. Start at the beginning of each. Negative 2 plus 0 minus 3. Negative 2 minus 3 is negative 5. Row 1, column 2. So now we're over to column 2. We're still in row 1 in the first matrix. Start with the first terms. 4 plus 0 plus 3 is 7. Row 1, column 3. 2 plus 0 minus 3 is negative 1. And now we're back to column 1, but now we're using row 2. Cross the row, down the column. Negative 4 minus 1 is negative 5. Plus 2 is negative 3. Row 2, column 2. 8 plus 0 minus 2 is 6. And row 2, column 3. 4 plus 0 plus 2 is 6. There's our product matrix. Letter B, 2 by 2 matrix times a 2 by 2 matrix. Middle numbers match. Product is our outside. We're going to get out a 2 by 2 matrix. 2 rows, 2 columns gives us 1, 2, 3, 4 entries. Row 1, column 1. Row 1, column 1. 3 plus 0. Row 1, column 2. 3 times 0 is 0. 4 times 1 is 1. 4. 0 plus 4 is 4. Row 2, column 1, negative 2 plus 0. And row 2, column 2, 0 plus 5 is 5. Number 7. Once again, we have a 2 by 2 times a 2 by 2. Middle numbers match. Outside product, we're going to get a 2 by 2 matrix. Row 1, column 1. Row 1, column 1, negative 1 plus 2. Row 1, column 2, 2 minus 2 is 0. Row 2, column 1, negative 1 plus 1 is 0. And finally, row 2, column 2, 2 minus 1 is 1. Now, when we have a square matrix that has 1s on the diagonal and 0s everywhere else, that is called the identity matrix. We'll talk more about the identity matrix in the next lessons, but know that an identity matrix simply means that it is a square matrix with 1s along the diagonal and 0s in every other position. Letter B, we have a 1 by 3 matrix and a 3 by 1 matrix. Middle numbers match. We're going to get out a 1 by 1 matrix, which means we're going to have one single entry, which is row 1, column 1. So I'm using row 1 with column 1. 2 plus 2 is 4, minus 3 is 1, and there's our product matrix. Last one here, number 8. We have a 3 by 1 matrix and a 1 by 3 matrix. Middle numbers match, and we're going to get out a 3 by 3 matrix. Three by 3 matrix. If I put in the positions to help us stay organized here. Row 1, column 1, 1 entry. 2 times 1 is 2. Row 1, column 2, negative 4. Row 1, column 3, negative 6. Row 2, column 1, negative 1. Row 2, column 2 is 2. Row 2, column 3 is 3. The last row is 1, negative 2, negative 3. Letter B, we have a 2 by 3 matrix and a 3 by 3 matrix. Middle numbers match. Outside product, 2 by 3. Row 1, column 1, negative 3, plus 4, plus 3. I'm sorry, negative 3 plus 8 plus 3 is 8. Row 1, column 2, 2, minus 4, plus 6. Row 1, column 3, 1, plus 0, plus 3 is 10. Row 2, column 1, negative 6, minus 20, plus 1 is negative 25. And row 2, column 2, 4, plus 10, plus 2. Row 2, column 3, 2, plus 0, plus 3 is 5. All right, we're going to take a look at one of these now on the calculator so you can see how these can be plugged into your calculator. Let's look at that last one that we just did on the calculator. Go into your matrix menu. So you hit second function, X inverse, which gets you into your matrix menu. Arrow over to edit. Put in the dimension of your first matrix. Our first matrix there is 2 by 3. Enter that in, and now enter in your matrix. 1, 2, 3, 2, negative 5, 1. Make sure you hit enter on that last entry so it stores it up here in your matrix. Exit out of that menu. Second function, quit. Go back into your matrix menu. Now we need to edit our second matrix. So arrow down to B. This time it is a 3 by 3 matrix. And enter that in. Negative 3, 2, 1, 4, negative 2, 0, 1, 2, 3. From here, go back into your matrix menu. We want to take matrix A times, back into your matrix menu again, arrow down to B, A times B, hit enter, and there is your matrix, same thing that we got by hand. Remember, you will have to be able to do it both on calculator and by hand, so make sure that you are learning both methods.